Okay, we got Sasha the Wonder Dog, the Wonder Math Dog here. She's going to be helping us out. She's going to be telling us what the first answer is going to be for number 37. Sasha says A. We're going to find out if she's right. Let's go ahead and take a look here. Okay, well, we're going to find out, is Sasha the Wonder Math Dog, is she right or is she right? She's sitting right here. She's so excited. She says A. Here we go. All right, Ken and Tammy are making necklaces. All right, so Ken makes 25 necklaces. That's going to be important. Tammy makes M more necklaces than Ken. Okay, and we better circle this. M more necklaces than Ken. Which expression, expression means going to be no equal sign, represents the total number of necklaces Ken and Tammy made? Okay, so what we've got, I'm going to put these in a bullet form again. We have Ken, and he has 25 necklaces. You're going to have to wait, Sash. We're going to work out this problem, see if you're right or not. So there's Ken. Whoops, that's a K. Ken, 25. And then we have Tammy is M more necklaces than Ken. So what I'm doing is I'm sketching everything that I circle. And this is a great way to do this. Now you know you've got the different parts, okay? Have a seat, Sash. Tammy makes M more necklaces than Kim. So we're going to take Ken. So Tammy is Ken plus M. That's what it means. M more necklaces than Ken. Just take it exactly what it says. M more necklaces than Ken. And just write that down. Ken plus M. And then we need the total number of necklaces. So we need and then we need an expression. Okay, so now we just put these parts together. So we have Ken. I mean, think about this. We just have Ken plus Tammy, right? Equals the total number of necklaces. That's really what we're doing. So we have Ken, we know what he makes, 25. And then we got to add Tammy. So what is Tammy? Well, Tammy she is Ken plus M. Okay? So Tammy could be 10, we'll put this in here, Ken plus M. Okay? And then I better take off that, I better take off that total because we're talking about an expression here. I don't want to confuse anybody with that. Okay, so we have 25 equals Ken plus M. Let's make that a little neater so we can see. It's hard to write on the screen vertically. That's the problem with this. I can't set it down. So that's Ken plus M. Okay? Now this isn't one of the choices, but we know that Ken is 25, so it's really 25. There's Ken plus, and then we have Tammy, which is Ken, and we know he's 25 plus M. Okay? So altogether, that's how we would get our total. And it looks like, ladies and gentlemen, Sasha the Wonder Dog is correct again. So we're going to give her a treat when we do the next one here. Okay, so here we go. Good discussion. Let's go look at the next one. Okay, so we're back with Sasha the Wonder Dog, and we're going to give her a treat. She did such a good job. Good job on the last one, Sasha. Good job. Good job. There you go. Eat them up. Eat them up. Eat them up. Okay, I want to let her read this problem now. Take a good close look, Sasha. Okay, let her read that one. Okay, she's going to get good there. See what's going on there, Sasha? Read it. Okay, now let's look back at the answer choices and see what she's going to say for that one. Okay, and then she's going to think about that, and she's going to... Okay, so we actually had to go for quite a long break there. So Sasha carefully, she read this one, and then it took her a while, but I think we've got what she's looking at. All right, so let's get her final answer. So Sasha, come here. What are you going to do for this one? Oh, she's going to do a C. All right, so letter C. This is a tough one. All right, okay, Sasha, letter C, and I'll give you a treat later. Okay, bye, down. All right, so let's take a look at this one. Letter C. Okay, so here we go. This is something you haven't done yet, but it's skills that you know. All right, so here you go. It says Kira decorates the exterior faces. So you can kind of guess what that is. You can kind of guess what a face is. See if I can get my line of a gift box in the shape of a cube. So basically, if you were to fold this up, you would have a cube. Okay, you'd have a cube that maybe would look something like this. Okay, so you'd have this cube. This is what this gift box would look like. Okay, it'd look like a box. Okay, in the shape of a cube. And it's got 6 sides to it. So it's just like a present, just wrapping a present. That's all you're doing. Okay. And the figure below shows the net of the gift box. So the net is the new word. So circle that word. And a net is just the box taken apart. The box unfolded. That's all it is. The box unfolded. No big deal. Okay. And you're trying to find out. Let's get down. Well, we'll get down to our question down here. You're trying to find out what is the surface area. So again, that's a new concept, a new term for you, but you already know area. Area is just if you have, say you have a shape like this, and one side is 6 and this side is 6, you know that an area of any rectangle or square is length times width. So area equals the length times the width. So the area in this case is 36. It means it would take, if these were inches, again, what this means is it would take 36 inches, or square inches, I'm sorry, it would take 36 square inches of material to cover this box. We can actually draw the squares on here. So that's actually 6 inches and then 6 inches, we're pretending, and so there'd be 36 of those squares. So if that was wrapping paper, you would need 36 square inches. And if you look at a roll of wrapping paper, it'll tell you how many square inches are on the roll. So this is an actual problem. In companies that are gift wrapping things, they have to figure out how much paper do we need. So they use this exact math. So Sasha thinks it's going to be 253 square inches is what she's thinking here. She's pretty smart. Pretty hungry too. So that's supposed to be square inches. Let me fix that for you. I think it says it up here anyways in your description. Okay, so let's go figure out, like, how do we do that? How do you figure this problem out? Well, again, let's use what you know, okay? Let me get a different color here. So what you know is you know about area. Surface area just means all the sides. So in other words, look at my drawing. It means the top, okay? That will be our top. It means the bottom. Whoops. Maybe I'll go to a little bit of a darker green than that. Okay, hold on here. So this is the top, T-O-P. It means what's the area of the top? What's the area of the bottom? And then you have the side. And then you have the other side. And then you have the front. And you have the back right here. So you have 6 sides. So there's 6 sides in a cube, and you can see the 6 sides here. So here's the bottom. Okay, here's the bottom. I'll just put B-O-T-T. Okay. This and these are where you would fold it, right? So you would fold this up. That would be the side. This would be folded up. It would be a side. This would be the back. This would be the front. And this would be the top. So there's 6 sides. And you're supposed to find the surface area, which just means find the area of all 6 sides. And in this case, it's not too bad because they're telling us one side is 6 1/4 inches. And we know this is a cube. So that means that all the sides are the same length. Okay, so this is also here is going to be 6 5/10 or 6 1/2 inches. So really all you have to do is just find the area for just one. So you're going to find the area for one of these. And then think about that. What could you do if you know the area of one of these sides and they're all the same? You could just add those up 6 times or multiply them by 6. You got it. You got it. Not too bad. So the other thing we want to do is let's just do a little estimation here, okay? Because if you estimate first, this will help you with your final answer. So let's just round these. So this is 6 5/10. So that's about 6 5/10 is about 7. So you could think to yourself, 7, 7, just to estimate, okay? Length times width, 7 times 7 is what? So if you know your math facts, 7 times 7 is 49. So that would be 7 times 7 is 49. And you know what? 49 is awfully close to 50, and that's a friendly number. That's a really easy number to work with. So if we just estimate in our heads that this is 50, that means we have 6 50s, right? 6 50s. So let's just think about what that would be. So we'll do 50 times 6. And of course, all we need to do is do the multiplication fact. 6 times 5 is 30. And we can, times 10 is literally what we're doing right there. So that's 300. So if you look at your answer choices, you can eliminate. You can say, oh, it can't be this one, and it can't be that one. It's going to be closer to 300. So it's got to be one of these two. Okay. Now we know it's going to be less than 300 because look, we rounded up not once but twice. So we know our estimate is high because we round it up. I want you to think about that. Okay. Well, let's go ahead and find out what it actually is here. Let's find the actual area of one of those. So I'm going to move this. I'm going to take this part off, but I would like you to, just have extra paper with you. But I'm just going to use this part here. So I'll take this off. The net is just the box unfolded. And let's do the actual. Okay, so our estimate helped us to get rid of 2 answer choices. Now we're down to 2, just 2 answer choices. So let's do the actual here. And we'll do that with the purple. So it's going to be area of one side equals length times width. The area equals 6 times 6 and 5/10 times 6 and 5/10 inches. Let's do that math right here. 6 and 5/10 times 6 and 5/10. This is a good place for you to stop it, do your work, and then check it. I'm just going to keep going. 5 times 5, 25. Okay. And I don't have to line decimals. Remember, I'm going to, at the very end, that's where I'm going to take care of the decimal placement here. 5 times 6 is 30, plus 2, 32. Okay, I'm going to move over. I'm done with this one, with carrying that. I've already used that value. And I'm going to move over and multiply everything by the 6, which is in the ones place. 6 times 5 is 30, 0 and 3. 6 times 6, 36, plus 3 is 39. So I have 5, 2, 3 plus 9. Oops, 3 plus 9 is 12. I guess I'll put my plus sign right here, sorry. Take that off. It's not confusing anybody. And 3 plus 9 is 12. 2, carry 1, so 42. And then I have tenths times tenths. Remember, we talked about that. So you have 1/10 times 1/10 equals 1/100th, and that tells me I have to have a decimal or a number in the hundreds place. So this is 42 and 25 hundredths inches squared, or square inches, and I can write it like that. That's for one of those. So that's for one. So I have how many of those? 1, 2, 3, 4, 5, and 6. So let's see, we've got, even right now, I can tell, it looks to me like Sasha's going to be right because that's close to 40, and 6 times 4 is 24, so it's going to be more than 240. It's probably, I think she's going to end up being correct here. So let's take a look. She's a pretty smart dog. All right, here we go. So we're going to do 42 and 25 hundredths, and of course you can stop and catch up and go back anytime, times 6. Okay, again, why times 6? Well, I found the area for one side. And now I have to find the surface area. That's our new term, which means the area for the whole cube, all of the sides of the cube. Again, I'm multiplying. I don't have to have my decimals lined up because I'm not. I'm multiplying. I'm making copies of each thing. And when I'm done, then I will place the decimals. So here we go. 6 times 5, 30. 6 times 2 is 12, plus 3, 15. 6 times 2 is 12 plus 1, 13. 6 times 4 is 24, 25. And I have hundredths, so I literally have a hundredths times just 1. So literally what's going on here, the reason I'm going to have the decimal placement is I have 1 hundredths, because that's where my decimal is, times, there's no place value here, So I still have to have my decimal in the hundredths place. I have to have digits in the hundredths place. So there we go. There's our final answer, 253 and 50 hundredths. And it should be inches squared, or you can see it written as square. They'll write it both ways, square inches. And that's how material comes. That's how paint comes in tarps. Let's see if Sasha the Wonder Dog was correct. 253 and 50 hundredths. And ladies and gentlemen, she is going to get a treat for that. What an amazing dog she is. All right, bring her out here after a little bit and we'll give her a treat. Let's pause and take a look at the next one. Okay, 6th grade, let's take a look at this one. This is a multi-step problem. So you got a lot of steps going on. So you may need some extra paper. Make sure you've got some extra paper to work with, okay? And there are of course different ways to do this, but this is a very much a real life problem. It says David made a class banner, so a banner, out of a large rectangular piece of paper. So in other words, he started with this piece of paper that was in the shape of a rectangle, okay? And then it says he cut a triangular piece out of one side as pictured below. So he kind of basically what he did is he cut a triangle out like this. Okay, does that make sense? He cut, except it wants to erase my whole thing, so I'll have to go back and put it in like this. So he cut the triangle out. I'm not sure why it erased all of that, but you had this part here, and then he cut the triangle out of it, okay? And that's what's looking like. That's why it looks like this one over here. Except for when I tried to do dashes, it really made it look horrible, didn't it? And that even made it look worse. But you get the idea. So let me get that out of here because that's a terrible drawing. But it's hard to write on this because I have to do it vertically here. Apparently it's hard to erase also. Okay, so this is just really wants to give me a hard time here. Okay, so here we go. So this is a real life problem because, make sure I got something to write with. And so what they want to know is, well, what's the area in square inches of the banner? Okay, so in other words, what's the area of this whole space in here? And see if I can get this to color in. Will this color in? Won't color in for me? No. Why won't it do that? We don't know. Well, for whatever reason, it is saying it doesn't want to do that for me. So let me pause here real fast. Okay, well, the highlighter does not want to work, but that's okay. So again, they want to know what's the area. Okay, so in other words, how much material would it take to make this banner? So the area is the inside. So we can, instead of using the highlighter, I'll just kind of highlight, sort of use the pen with this yellow here. So this area on the inside here. All right. Now, if the area was just simply a rectangle, boy, that'd be really easy, because then you could say, okay, well, look, I've got in this case I've got 3 inches to here, and then 5. That's 8 inches. So this side is 8 inches. I'll put it over here. 8 inches on that side, and then this top is 14. And this is 14. And of course, if I want the area, I just need to say, literally this means I have 14 rows, 14 columns, I should say, so you can imagine 14 columns and then 8 rows, and that would help me get how many squares in here. So that would be, area would be length times width. The area of the whole thing would be 8 times 14, or length, actually, let's turn those around. Length is usually the long side, okay? It'd be 14 times 8, and I could just do 14 times 8 over here, or I could do it mentally and say this is like 10 plus 4, so 8 times 10 is 80, 8 times 4 is 32. I could add 80 and 32 and think about what I would get there, right? What would that be? 80 and then 32, so 80 and 20 is 100, and then another 12, so I'm like 112. Let's see. So 8 times 4 is 2, 3, 8 times 1 is 8, 9, 10, 11. So the whole thing, that would be super easy if it was just a rectangular banner. Let me correct that really fast. 112 inches squared. Okay? So if if we could just do the whole thing, that would be easy. But he cut a piece out of it. So he cut this section out. Okay, so this section here has been cut out of the banner. So the question is, how do you find it now? Well, one of the things you can do is think about those big ideas. So we already talked about our big idea of area. Another big idea is holes and parts. Really comes back to this over and over again. This one you see all the time. So in fact, you probably are maybe even thinking of this already. We could pretend, if we pretend like that triangle was not cut out, then we know the whole thing. And we just found that. So the whole area inside here is 112 inches squared. Okay, so we pretended again like that wasn't cut out, and we did our length of 14 times our width of 8. We did that work down here. So we know this inside, the whole thing is 112 inches squared. So what we could do is just go back and subtract this triangle. And we can do that because you know the area, how to find the area of a triangle. So if you want to find the area of a triangle, okay, that is, area of a triangle is 1/2 times the base times the height. And I think you had just started doing that. Okay, so that's a formula for the area of a triangle. The reason that works is because if you have a rectangle, that's length times width. And if you cut a rectangle in half, then you get the area of a triangle. Like I could get the area of this triangle by saying, hey, I'll take 1/2, the area equals, I'll take 1/2 of the length times the width, right? The length, I'll take 1/2 of the whole thing. And so that's where that formula comes from. But a triangle doesn't have a length and a width, but it does have a base like this one and a height. So we're going to take a look at that. Okay, so here we go. Okay, so I'm back here. All right, we were just looking at taking this whole thing and taking the triangle out. So we know that the area of a triangle is 1/2 base times height. And so we know the base of this. We can look at the base, bottom. See if we can get that color to come in. We know that that is 8 because over here, 3 plus 5 is 8. So we have 8 inches. Now the height is basically the tallest part of a triangle. Okay, so if you have a triangle that's a right triangle, well then the height is the same as the side here. That's the same as the height. But if you have a triangle, it's hard to draw that. If you have a triangle that is sort of like what we have here, then the tallest part, you can imagine, this is the widest part or the tallest part of the triangle. So we're talking about from here, just continuing with this line, straight over. And you can figure that out because, think about it, you got these clues. This is 11 inches from here to here, but the whole thing is 14. So this would have to be 3. Because 11 plus 3 would be the whole thing 14. So now we can come down here and we can say 1/2 times the base, which is 8. So I'm going to put a little dot there, times 8, times the height, which is 3. And because of the commutative property that you learned starting in 3rd grade, it doesn't matter what order you go in. So you can take 1/2 times 8. You can do that first because that's really easy. 1/2 of 8, half of 8 is another way to think about that, is 4. And 4 times 3 is 12. So the area equals 12 inches squared. So now our final step is to go back. Let me get this out of the way here. Our final step is to go back and say, well, let's look at the whole thing. So our whole thing was, we decided, that was over here. Our whole area was 112 inches squared. So 112 inches squared. It's probably a good idea just to keep your units there, minus the triangle that he cut out, which is 12 inches squared. So 112 minus 12 is just 100. So it's 100 inches squared. And this is a very realistic problem because there are many companies that are cutting out products, okay? Like maybe this is an actual banner, so they have to buy the whole sheet of of plastic or canvas, okay, like you see a lot of these banners, the whole sheet, and then they have to figure out how much to cut out. Let me pause this and get the phone. Okay, so I've got, looks like my webcam piece is not working anymore, but we'll finish up this one, and that should do it for this video. So let's see if we can get this going here. Okay, so here we are. We've got this whole thing. We subtracted, and we got that all together, finished it all up, and we found out that after we subtracted the total rectangle minus the triangle, this was in fact the banner. So there's our final answer right there, 100 inches squared. So super great job, and we're going to call it for this one, and then I'll upload it, and we'll see you in the next video. Thank you for coming to give us her answer.